Hey guys, Andrew from Seemu here, and in this tutorial we are going to look at placing 2D objects in ARKit, so two little guys and a soccer ball bouncing in between them, and then we'll update to be Pong based images, which will show you guys how you might begin implementing 2D Pong in ARKit. So let's get into it. First of all, you want to go to your main.storyboard, and in the Object Explorer in the bottom right, you want to search for ARKit, and the one we want to use is ARKit Scene View. So we'll drag that onto our view controller, and you may be wondering what the difference is. Sprite Kit View is meant for 2D objects and Scene Kit View is meant for 3D objects. So why are we using Scene Kit View for 2D objects when it's used for 3D objects? Well, the thing is, you can actually display 2D objects in Scene Kit View. If you display them in Sprite Kit View, it all works well and good, but when you start trying to do animations and moving around 2D objects in a 3D space, it gets quite tricky to actually code and implement. So it's a lot easier to use a 3D world to show 2D objects in. So with our scene view in the storyboard, once you've got it to take up the whole screen, adding constraints to the top, left, bottom, and right, as follows. And that will take up the whole screen. And just a quick note, ARKit can only run in iOS 11 onwards, and any devices with an A9 chip, which are listed in the description below. So with that done, we'll want to hit our assistant editor, drag the AR scene view into here with the control key, and connect it up as an outlet named scene view. So SCENEVIEW. Once that's done, head on over to our view controller and let's start coding ARKit. So first of all, in our view controller, under import UI kit, we want to import ARKit and import Scene Kit to import the required libraries for our ARKit application. Next of all, we need to add a function called view will appear, and that will autocomplete once you start typing it in. And in this, we'll do let configuration equals AR world tracking session configuration brackets scene view dot session dot run, and in that brackets configuration, and we're going to set the scene view dot delegate to self, so we're going to delegate its methods to this class, and that's where we'll stop for now. Don't worry about that error, we'll fix it soon. What we need to do is first we'll go file, new file, and we're going to create a Swift file. Going to name this file string, save that. And in the string file, I'll include a link in the description. You'll want to copy and paste the code from pastebin in that link to create a string extension. And essentially what this extension allows us to do is to turn a string into an image. So we're going to turn emojis into images, which can be used in our ARKit. Once you've pasted that in there, we'll head on over to our view controller. And if you want to know how extensions work in Swift, be sure to check out the video in our description below, which covers it in more detail. So back in our view controller, after UI view controller, we're going to want to add a comma and add the protocol ARSCN view delegate to our view controller. And that will begin to set up the required delegate functions for our sceneview.delegate. And we want to add a function called render. And the one we want to select is renderer did add node, SCN node, and for AR anchor. And we'll get back to filling this code in later. Now under C view, we want to do var ball node equals scn node brackets, and var anchors equals and then var anchors colon AR anchor, an array of AR anchors equals an empty array. Okay, next up, under view will appear, we're going to create a new function called function make 2D node. This is going to take in an image of the type UI image. Next in, it's going to take the width as a CG float, and we're going to set it to be 0.1 by default if we don't pass in the width parameter. And finally, the height as CG float equals 0.1 as well. And this function is going to output a scn node. Now in this function, we'll do let plane equals scn plane, the width being the width and the height being the height. Next up, we'll do plane dot first material exclamation mark dot diffuse dot contents equals image. Then we'll do let node equals scn node, and in brackets we'll do geometry plane, do node dot constraints, and in the constraints we'll do an scn billboard constraint, brackets, and close off that array, and then we'll return the node at the end. Alright, so what this function is doing is you pass it in an image. The width and height are optional. If you don't pass them in, they'll be set to 0.1. Essentially, it's creating a node which we can place in our ARKit world, and that node will always be pointing towards the camera, so we can place a 2D object that will always be pointing at the camera. No matter what angle you're looking at it from, it will look exactly the same. So with that function, we're going to use that in view will appear now. And how we are going to use it is we're going to do ball node equals make 2D node, and we're just going to pass in the image. And what the image is going to be is the soccer ball emoji, which I'm going to paste here. And now using the string extension, if we do dot image, curly brackets, exclamation mark, close that off, that's going to create a node which can be placed in our ARKit world, which is going to use the soccer ball emoji as its image, which you saw at the beginning preview. Alright, so the next function we're going to add in is function touches began. And in this code, we're going to do if anchors dot count is greater than 1. We'll do return, and we'll come back and fill this in later. And now I'll do if let current frame equals scene view dot session dot current frame, and in here we'll do var translation equals matrix underscore identity underscore float 4x4, and I'll get back to what this is soon. And then we'll do translation dot columns dot 3 dot z is equal to minus 0.3. Don't worry if you don't understand this, I'll cover it all off soon. And I'll do let transform equals simd underscore mul, and in this brackets we're going to do current frame dot camera dot transform, then we'll do comma and add the translation in there. Finally, we're going to do let anchor equals AR anchor. In that brackets, we're going to do transform and pass in transform. Now we'll do scene view dot session dot add, and in that brackets, we're going to add the anchor to our ARKit scene view that we just created with the let, and then we'll do anchors dot append and add the anchor to our anchors array. And this touch as begins needs an override at the beginning also. So what we are doing in this function, if we have more than one anchor, we're going to return, and we'll fill this in later. What this block does is it gets the current frame of our scene view. Now it creates a translation variable, and what this matrix identity float 4x4, it's a way of identifying a 3D point in space using a 4x4 matrix. And essentially this translation we set to minus 0.3. And what this is doing, it's going to get the camera's current position in ARKit and set the position of the anchor we'll be placing to be 3 centimeters in front of the screen. To be in front of the screen by about 3 centimeters or so. So this is set by the transform, and finally we place our anchor on the screen. So that's all well and great, but what are the anchors we're placing on the screen? How do they relate to actually placing stuff like a ball and soccer players on the screen? That's a great question, and how it works is when we add an anchor to the screen, the AR scene view delegate is going to call this renderer function, in which case we can actually attach an image or 3D object to that anchor in our ARKit world. So to do this, it's quite simple. We're going to copy this make 2D node code for the soccer ball, and in render we'll do let player equals make 2D node with a soccer ball, and what we are going to use is the running man emoji. So I'll just get that now. So place the running man emoji in there, and on the next line we're going to do node.add child node, and in the add child node we're going to add player. Now that we've done that, if you want to run the app now, you can see it in action. You can point your device around the ARKit world, and if you tap on the screen, you can add up to 2 running man emojis on the screen, which are in 2D. Now what I'm going to do is going to show you how to add a soccer ball, which will bounce between these 2 emojis, which is pretty cool. So to do that, we're going to add a function called start bouncing. So func start bouncing. First of all, in this function, we're going to add a guard statement. And in the condition, we're going to do let first equals anchors dot first, comma let start equals scene view dot node, and in brackets we'll do for first, so for our first anchor. New line let last equals anchors dot last, comma let end equals scene view dot node, in brackets for we'll do last, and then in this else, if we call it, we're going to do return. And to make sure after the start we add in a comma as well, otherwise it will complain and show an error. So what this is doing is ensuring we have our first and last anchor actually exist. And from our scene view, it will also grab the first and last node. If they don't exist, we'll simply return the function and it won't do anything. Next of all, do if ball node dot parent equals to nil. Then we do scene view dot scene dot root node dot add child node, and we're going to add the ball node as a child node. So this is only going to be run if the ball node has not been added to our scene view. If it has, we don't need to re-add it again since there'll only ever be one ball. Now do let animation equals CA basic animation brackets key path, and in the key path we'll do hashtag key path brackets scn node dot transform. Close that off. Then we'll do animation dot from value equals start dot transformation start dot transform animation dot to value equals and dot transform. Then we're going to do animation dot auto reverses equals true. Then animation dot repeat count equals dot infinity. Then we'll do ball node and we'll remove any existing animations from it. So dot remove all animations. And finally we'll do ball node dot add animation. And the animation is going to be the animation we just created, and for key is going to be nil. So let's run the app now, and then I'll go over this code with you guys. Quickly before we run it, this start bouncing function, we need to add one more line of code in this function, which is animation.duration here. And this is going to be how long a full animation takes to complete, and we're going to set that to 1. And finally, in the touches began in anchors.count greater than 1, what we need to do is to call our start bouncing animation to make a ball bounce between two soccer players in ARKit. So once you've done that, let's run the app. Alright, so how cool was that? We created our first 2D nodes in ARKit, and we also made a soccer ball bounce between them. So what's happening in this start bouncing, essentially, it grabs the first anchors and last anchors, the start of our scene view nodes and the end of it, and basically it will create a ball that will begin from our starting node and at our ending node. The animation is going to take 1 second to complete, so you can play around with the timing in here. Auto reverses equals true means the animation will reverse once completed, and we repeat the animation forever. And if the ball has any existing animations, we remove them, then add the animation to bounce between the nodes. So that's essentially how that works. So now that we've been using emojis for ARKit, let's actually use some images. So go to our assets.xc assets. And so what I've done, I've went ahead and already prepared some images, which you can download in the description below. So drag them into our assets.xc assets. We've got a blue paddle, a red paddle, and a ball. If we head back over to our view controller. Okay, so what we want to do with our images now, we're going to head over to our ball node equals make 2D node. And in the images we added, we have a ball and 2 paddles. So the ball node, we're going to get rid of the soccer ball, add our ball image in there. And for our player, we are just going to use a blue paddle for the sake of the argument. So add a blue paddle, which is called paddle blue, not blue paddle. So paddle blue, and we see the little blue paddle here. And what we also need to do for the ball node, we are going to add a width of 0.3 and a height of 0.3. So essentially what we're doing, we're making the beginnings of a Pong game in ARKit. We have 2 paddles and also a ball, which we're setting to be smaller than a paddle. And the width was actually going to be 0.03 and the height is 0.03. So let's run that now and see Pong in action. So as we can see here, we have our virtual Pong paddles. Now if we go back, we can see Pong in VR. So you could then modify this game and extend it so the ball actually bounces around the real world and you could have a virtual AR game of Pong. Alright guys, you can download the source code for this application below. Don't forget to subscribe for more tutorials.